Today I am going to present the digital image classification, which is one of the important aspects in image processing, that is the digital image processing. Processing operation. So in image classification, what we have done is basically that we have separating the image or separating the pixels into finite number of individual classes. So it is a process of categorization of all pixels into an image of predetermined number of classes, into an image of predetermined number of classes. Alternatively, we can say the task of extracting information classes from multi-band or multispectral image. For example, this is an image. So if we can classify the image, suppose this is a built up area, this is the area covered by the natural vegetation. Suppose this area is water body, this is a cropland, and this is agricultural fallow land. So the entire image has been divided into the 1, 2, 3, 4, 5, 6 number of classes. So this resulting raster image that can be used to create a thematic map. Right? So this classification method that is based on some succeeding operation like the pattern of DN or digital number, that is usually derived from multi-channel data, Second, spatial relationship with neighboring pixel, Third, that is the relationship between the data acquired. And time. Acquired on different dates or different periods. So these are the three basic succeeding assumptions based on which the classification process is adopted. However, this classification process, that is the land use land cover classification process, that first proposed by Anderson, and this classification is based on its level. What is the level? That is, it refers to the degree of details. It represents the degree of details, or we can say the scale of the classification. For example, level 1, level 2, level 3, level 4. For level 1, the agricultural land. So agricultural land has been divided into crop land and agricultural fallow land. Okay. Next, crop land is, suppose, different types of crop. It may be types of crop pattern, seasonal crop, etc. So when you are going to the level in details, so we will get the degree of details of the classification. Now the types of classification, which is one of the basic important of the digital image classification technique. First, the classification has been categorized based on the methods that we used in the classification process. For example, we can say the hard classification. That is the hard classification. It refers to the classification using the discrete number. Classification using discrete numbers. For example, this hard classification is basically divided into the supervised classification and unsupervised. Next, coming to the soft classification. The soft classification, that means it will consider the heterogeneous nature of the real world features. For example, this is an area. So there may be the vegetation, there may be the water body, there may be the built up area. So all these features are come into the single pixel. So in that case, we will consider the soft classification to separate the vegetation area, to separate the water body, to separate the built up area. And the third one is the hybrid classification approach. This classification, that it includes the expert system and the artificial intelligence. Here we also use the ancillary information to classify the image. Also expert system or expert knowledge or artificial intelligence. Now, based on the statistical characteristics, we can also classify the digital image classification into parametric, that means the data are normally distributed prior knowledge of the class density. Here we are generally use the maximum likelihood classification algorithm in parametric, which is also known as MXL. There will detail discuss later in our next classes. Next, It can also classified as the non-parametric. That means there are no prior assumptions required. For example, the nearest neighbor classification, fuzzy, neural network. So these are the example of this non-parametric classification technique. And another third category is the non-metric. This classification that can operate on both the real value data and the nominal scale data. So these are three basic characteristics of the image classification technique, which is based on the statistical characteristics of the data. Now we will study about some following steps of classification. What are the steps that will be used in general classification process? First is the selection of the classification scheme. Classification scheme that it can be the level 1 classification or level 2 classification or level 3 classification or so on. Next, ground truth information collection. Ground truth, that means the field-based survey data that the team visit in the ground and collect the information or the number of sites where the features of interest are located. After that, the location and the extent of the features that can be precisely demarcated in the image to classify the image. Next, third, that selection of training sites. What is the training site? That is the pixel used as a training set that is collected from the fields and should be scattered around the image to capture this variability of the reflectance of the features. And each of the training set that should have the 10 into n to the power pixel per classification category. Whereas n, it will indicate the bands of the multispectral image. Multispectral image. Step 4. Evaluation of the training pixel. This training data should be normally distributed. That can be, we can test it through histogram analysis to determine the pixel distribution values of each of the training set. Fifth, comparing the spectral signature and signature extension. Here the selected training areas that is drawn on the image and around the certain areas on the scatter plot, and if there is a significant overlay between this scatter plot, this is the bad because it indicates that training sets are similar. Therefore, this would indicate the training pixel represent one category features, the unimodal distribution values of the training dataset. Next is contingency table preparation. These contingency tables that overlays the ground truth and classified pixel to determine how well they match up. As these training pixels are known to be given features, and this classification is based on this training set that should be work extremely well for these locations. Next, choose the classification algorithm. That it may be supervised, unsupervised, or it may be the parametric, non-parametric. All these methods that can be chosen in this process. Next, that is classified map generation. The digital map to be prepared based on this classification algorithm, and where we will use the training set, and if the classification process has gone well, the classified image will open up with the same colors assigned to the training classes. And the last, accuracy assessment. Here we will use the accuracy of the classified image and the raw data and the information that will be collected from the field by the survey team. Here we are comparing between the derived output and the information collected by the ground. Here we will calculating the producer accuracy, user accuracy, and overall accuracy. In general, when the overall accuracy is more than 85%, then we can consider for this classification is right, or if the accuracy is much more higher, then this is providing more accurate information about the classifications. So basically, there are two most important classification processes used in last 2-3 decades, and to classify the image and to prepare the land use land cover maps. And just outlining these two classification process. After that, we will discuss in the next classes. However, first one is the supervised classification. In the supervised classification, it is also known as the human guided classification technique. In this classification technique is most often used for the quantitative analysis of the remote sensing data, and this is basically based on the idea that a user can select some samples in an image and that are representative of the specific classes, and then direct image processing software is used to using this training set or reference set, the image will be classified. Here the training set, that is also known as the testing set, that is selected based on the knowledge of the user. And another important characteristics of this classification technique, that the user also sets the bounds for how similar other pixel must be to group them together, and therefore this bound has been based on the spectral characteristics of the features. Characteristics of these features. And the user also designates the number of classes here before the classification, running the round of the classification algorithm. Whereas in unsupervised classification, also known as that this is calculated by the software, especially image processing software. Here the outcomes are based on the software analysis. without using any sample classes. The computer uses this technique to determine which pixels are related and groups them into classes. User can specify the algorithm. There are several algorithms is used like isodata, K-means cluster, or clustering method. There are three most important classification algorithms used in unsupervised classification technique. And the desired number of output of classes also be defined. That it may be the 20 classes or 50 classes. However, the details of the classification algorithm of the supervised, unsupervised and other classification technique we will discuss in our next class. Thank you so much for watching this video. Please subscribe the same.